This section is on directed graphs, or called digraphs. So a directed graph or digraph is when we have edges with a direction associated with them. So if I'm going from A to B, or B to C, or B to D, or whatever. And these are really useful in asymmetric relationships. So, for example, I can go from A to B, but I'm not going from B to A, or C to B, but not from B to C. So the arrows are very useful here. In a digraph, instead of using the term edge, we're going to refer to each edge as an arc. And every arc is going to be defined by its starting and ending vertex. So in example B, we would write xy because we're going from x to y. And then in example C, it's the other way around. We start at y, we would say yx. So here's an example of an arc set and vertex set with a diagram. So sometimes you may be given an arc set and vertex set and asked to draw the diagram, or vice versa. So as you can see, we have CA, and that means starting point is C and going to A. So C to A. We have CB, so from C to B. We have DB, D going to B, and so on and so forth. The vertex set is just a list of the vertices, so we have A, B, C, D, E, and F. Some additional terms here. If XY is an arc in the digraph, and we say that vertex X is incident to vertex Y, or equivalently, that Y is incident from X. So I'm going to draw a picture of that really quick. So if we have X and Y, this would mean X is incident to Y, or Y is incident from X. And down below, if we have arc YZ, so first of all, let's draw these out. So if we have X, Y, and Z, and I have an arc going from Y to Z, and we also have arc XY. Okay, so YZ is said to be adjacent to arc XY if the starting point of YZ, that's right here, is the ending point of XY, which it is in this picture. So here's a digraph we can use for some examples. We can say, first of all, that A is incident to B, or we can say that B is incident from A. We can say that D is incident to C, or we can say that C is incident from D. Additionally, in a digraph, we would have a path. For example, if we had starting vertex X, and we ended maybe at vertex W. So if we had a sequence of arcs, so XY, YZ, ZU, and it continues until we get to maybe VW. As long as each arc, sorry, it says R, let's just say arc, as long as each arc is adjacent to the one before it, and no arc appears more than once in the sequence, then we have a path. And when the path starts and ends at the same vertex, we call that a cycle in the digraph. So for example, a path could be from A, D, and then D to C, or a cycle. Alright, so a cycle could be from A to D to E, back to A, ending at the same place that we started at. Back in chapters 5 and 6, when we were looking at Euler circuits and Hamilton circuits, we did discuss the degrees of vertices, but this time we're going to get a little more specific since each edge is directional. So in digraphs, we're going to call it either an in degree or an out degree. The out degree of vertex X is going to be the number of arcs that have X as a starting point. So how many arcs are coming out of vertex X, so outgoing. And then the opposite, the end degree, is going to be the number of arcs that have X as their ending point, so the arcs that are coming into vertex X. So here's an example again where we can say for vertex A, the out degree is going to be, we have 1, 2 arcs that are leaving vertex A, so we'd say 2. And the in degree, okay, and this isn't an official notation, I'm just writing it shorthand here, so the in degree would be just 1 arc coming in, so 1. Vertex B, the out degree would be 1, and the in degree, we have an arc coming in here and an arc coming in here, so that would be 2. And how about one more of these to finish this up? So for vertex D, the out degree would be 1, 2, with 2 arcs leaving D, and then the in degree would be 1, 2 as well. So now we're going to take a table of tasks along with the precedence relations and build a digraph from that table. So the first couple tasks on the table, A, B, and C, don't have any precedence relations. So those are going to kind of be our first round of tasks that can be ready to be completed. So of course we'll need a starting point. So we'll start here, and we can either go up to A, so task A, and we'll denote that A parentheses 3, and go to B, sorry, 4, or we can go to C, and that's 7 hours. So next, let's look at D real quick. A and B must be finished before task D can be complete. So we're going to draw arcs from A and B to D. And when you draw this, it doesn't really matter where you place the stuff as long as they're in the order. But since A and B are incident to D, we're going to put D in a good place for them. So how about right here? So D is a 6-hour task, or it doesn't really say hours, it could be minutes, seconds, days, whatever. And let's not forget to draw the little arrows here. Okay, the next task on the table is task E, which is a 5-hour task. The only thing that needs to be completed before task E is task B, so we could put that right here. And from B, we'll draw the precedence relation. Next is task F, a 5-hour task. Task D and task E need to be completed before we can do task F. So we're going to put that right here. So task F. So E is a must do before F, and so is D. And then the last thing on here is task G, which only E is the prerequisite for. So we'll put G over here. That's a 4-hour task. Okay. And to finish it all off, it's a little tricky at the end, but notice we have kind of stopping points at F. We end up kind of stopping at G, and at C as well. So there's not a whole lot of room on my screen, so I didn't prep for that, but that's okay. So to finish this, I'll need my ending point. So E or F for finish. And we're going to take it from F, we're going to take it from G, and from C. So all 3 of those arcs coming in to the finishing point at the end. And just to wrap up some of the vocab at the end here, here's a different example. We have a start and end point. We got all the tasks in between. So, for example, A, B, and C will be the first round of tasks. To recap, the in degree of A would be 1, and the out degree would be 1 as well. The in degree of B would be 1, and the out degree would be 2, because we have these two arcs coming out of there. A and B would be prerequisites for starting task D, as B would also be a prerequisite for starting task E. And just to recap again on the in degree out degree, notice G has in degree 1, out degree 1, F has in degree 2, out degree 1. And at the very end, all the points that we've ended at so far, we take those and bring those to our ending point.